Hello, Geometry Advanced. So today we're going to continue our study with circles, and we're going to focus on angles. So angles related to a circle. So some of the angles are going to have a vertex inside the circle. Some of them are going to have a vertex outside the circle. Some of them have a vertex on the circle. And then like we see here with the review, we have our central angles, which has a vertex at the center of the circle. So throughout this lesson, we're going to go through all of the different types of angles that somehow or another relate to a circle. So of a review of the first part, it says the vertex at the center of the circle is a central angle. We've talked about this already. But again, the measure of a central angle is equal to the measure of its intercepted arc. So if the arc is, like you see in the picture here, 70, then the central angle here would also be 70. Because again, the central angle is the same as the measure of the intercepted arc. So that one is a review. Next, for an inscribed angle. I know we talked about this briefly already. But besides an inscribed angle, you could also have a tangent chord angle. The reason it's called a tangent chord angle is because it's formed by a tangent and a chord, hence the tangent chord concept. But the way it goes is the measure of an inscribed angle, which would be like any of these cases, the vertex is on the circle, the sides are chords, or a tangent chord angle like we see down here. For either type, to find the measure of the angle, it's half the measure of its intercepted arc. So for example, in this picture here, angle V, vertex is on the circle. It's half of, again, the intercepted arc. So if you think of this as a Pac-Man, here's the mouth. If I'm chomping on it, chomping on the circle, the intercepted arc would be here. So angle V is half of whatever arc WX is. So I did an example off to the side here. So angle H, if I think of it as a Pac-Man, it would be half of whatever arc JK was. So if arc JK was 88, half of 88 is 44. In this situation, so we have angle F. So again, think of it as a Pac-Man, it's chomping on this arc. So if the arc, like I put here, is 120 degrees, half of 120 would be 60. So if the vertex is on the circle, as it is in an inscribed angle or a tangent chord angle, it's just half the measure of the intercepted arc. Okay, so we reviewed a central angle. We've talked about inscribed and tangent chord angles where your vertex is on the circle. Next, we have angles where your vertex is inside the circle, but just not at the center. So this happens when you have a chord-chord angle. The reason we call it a chord-chord angle is because it's formed by two chords. So here's one chord, WX, and here's the other chord, YZ. So again, you could have this angle here, XBZ, you could have WBZ, you could have WBY, or you could have YBX. You'd have four possible angles there you could find. But to find the measure of a chord-chord angle, it's half, not just half the arc, but half the sum of the measures of the intercepted arcs by the chord-chord angle and its vertical angle. So again, if you think of this as a Pac-Man, here's the angle that I want to find. So the intercepted arc would be this arc XZ, and then you have to take half the sum of that one and its vertical. So the vertical that goes with this would go this direction, and the arc that goes with its vertical would be WY. So again, it's half the sum of these two. So in the picture, again, angle XBZ, this one here, would be half of the sum of XZ and of YW. So I plugged in some numbers. So I said, okay, let's pretend that arc XZ is 100 and arc YW is 70. So I'm going to add them together and take half. So 100 plus 70 is obviously 170. And then half of 170 is 85. So that means this angle here, XBZ, is going to be 85 degrees. Okay. Last but not least, so again, we did central angles where the vertex is the center of the circle. We did inscribed and tangent chord where the vertex is on the circle. We just did chord-chord where the vertex is somewhere inside the circle. And then the last option is when you have the vertex outside the circle. So you have three different options here. So we have, this case, angle D. The vertex is outside the circle. It's formed by two secants, hence it's secant-secant angle. Okay, the second one here is called the secant-tangent angle because it's formed by a secant and a tangent, and again, the vertex is outside the circle. And the last type is a tangent-tangent angle, and notice again, it's formed by two tangents. The vertex is outside the circle. So anytime the vertex, like it says here, is outside the circle, to find the measure of the angle, it's half the difference. So if it's chord, it's half the sum, right here, half the sum. If it's vertex is outside the circle, one of those three, it's going to be half the difference of the intercepted arcs. Okay, so if I think about this first picture, a secant, the vertex is outside the circle. If you think of it as a Pac-Man math, it's chomping, it eats this arc and that arc, so it's half the difference of the two. So you're going to take the bigger one, which it looks like is arc AG, and subtract off the smaller piece would be arc BF, half the difference. In this picture, so again, it's chomping on this arc and this one. So to find the measure of angle J, it's half, again, the difference. So the bigger arc would be arc, it looks like GK, minus the smaller arc here, which would be arc HK. And then the last one, so again, if I put another point out here, let's call it Z, I don't know. So the measure of angle N, which is out here, is again half the difference. So the bigger arc would be arc MZP. Again, that's the major arc, minus the minor arc, which is arc MP. Now, in this kind of picture, so again, that's what I was just saying. In this picture, they're probably not going to tell you both arcs because the two of them together make a full circle. So if you know one piece, you should be able to find the other and then draw your conclusion. So again, we've gone over all the different types of angles that can be related to a circle. So if we take a look at this big picture problem for an example, so it says we are given circle O with a diameter of segment AD. We have tangents at line BF and line CF. We have secants at line PE. Let's see here, where's PE? PE is here, PD, and PC. Okay, so we probably need to draw that PC in. So PC would go like that. It's not drawn in the picture. Okay, we know to be given that angle DOC, so my central angle is 78 degrees. Angle DRE, that's a chord angle, is 82. And arc BC is 90. We want to find all of these parts. Okay, so one step at a time here. So to find, if I start with the first one, angle BFC. So BFC, notice the vertex is outside the circle. So to find angle BFC, it's half the difference of the two arcs. So one of the arc is 90. That means the other part, again, if it makes a full circle, would be 360 minus 90, which is 270. So to find angle BFC, we're going to take half of 270 minus 90. Because again, if the minor arc is 270, the major arc would have to be, or I'm sorry, if the minor arc is 90, the major arc would be 360 minus 90, which again is 270. 270 minus 90 is 180, and half of 180 is 90. So this angle is 90 degrees. Continuing on, number 2, angle CBF. So CBF has a vertex on the circle. So CBF, notice again the vertex is on the circle. So to find this angle, it's half the measure of the intercepted arc. The arc is 90, so half of 90 is 45 degrees. Okay, continuing further here. For number 3, arc DC. Okay, so again, if I'm looking at the picture, let me grab a colored pencil here. We knew angle DOC, which is a central angle, is 78. That means its intercepted arc here is also going to be 78 degrees. Okay, and again, continuing further here to find arc AB. Okay, so arc AB is this little piece here. And we knew that we had a semicircle from the beginning of the problem. So our semicircle is going to go from D all the way to A because it talks about AD as a diameter. So a semicircle is 180 degrees. If I know two of the pieces, 78 and 90, so if I add 90 plus 78, that gives me 168. So that tells me that arc AB, if I take 180 minus 168, this is going to be 12. So again, that's going to be 12 degrees. So we're 4 out of 10 here. Moving on to number 5, angle DPC. So if I'm looking at the picture, DPC is this one here. And let me grab a colored pencil here to make it easier. So DPC, the vertex is outside the circle, so it's half the difference of the intercepted arcs. So the two arcs we're talking about within this blue angle here are the 78 and the 12. So I'm going to take half of 78 minus 12. Well, 78 minus 12 is 66, and half of 66 is 33. So this angle DPC is going to be 33 degrees. We're halfway there. Okay, continuing on, we have angle BEC. So let me grab another color here. So for angle BEC, it's this one here in red. Okay, where's the vertex? It's on the circle, so it's half the measure of the intercepted arc. The arc would be this 90 here, so we're going to take half of 90, which is, again, 45 degrees. So this angle DEC is 45. Continuing on. Next, we're looking for angle DRC. Okay, so again, DRC is this one here. Now, let's make this easier on ourselves. They told us in the problem that angle DRE was 82. These two angles together make a straight angle. So let's use that concept. So a straight angle has a sum of 180. So if I take 180 minus 82, that gives me what? 98 degrees. So again, this angle is 98. I use the concept that, again, those two angles have to form a straight angle, and 180 minus 82 is 98. Okay, continuing on here. Next, we have arc DE. Okay, that is this one here. So there's different ways we can approach it. Okay, one of the ways is going backwards. If we know that this angle is 82, to find that arc, we would take half again. Let me erase that. So let's right up here where we have space. So my angle, which is 82, is 1/2 the sum of the intercepted arcs. So I don't know what arc DE is, so I'm just going to write DE. And then the arc that goes with its vertical is going to go from A all the way to C. So that would be 12 plus 90, which is going to be 112. So if I'm thinking I'm going to solve for arc DE here, the first thing I would do would be multiply both sides by 2. So 82 times 2 is 164. And then we have arc DE plus 112. So to continue solving, I would subtract 112 from both sides. So 164 minus 112 is 52. So again, the measure of arc DE is going to be 52 degrees. Okay, we got two pieces here yet. So angle EMA. So let me grab a different color again. Let's grab the screen. So again, EMA has a vertex on the circle, so it's half the intercepted arc. The arc has to go from E the long way all the way around to A. So it's half of the sum of those arcs. So I have to add 52 plus 78 plus 90 to get, and then finally, I almost forgot, plus that little piece of 12. So when I add that together, that's 232, and half of 232 is 116 degrees. Okay, and then finally we are looking for angle OCB. So angle, let's see if I can find it here looking at the picture. OCB. Okay, so think about this. OC is a radius, this is a tangent. Remember our theorems, a radius and a tangent are perpendicular. So that means that angle OCB is 90. Okay, so that is it on explaining the examples and the theorems for angles related to a circle. And as always, if you have questions, please let me know.